this exercise, we are going to learn to rewind a three-phase squirrel cage induction motor of a single layer distributed balanced winding type. Distributed type winding is the most common type of winding found in three-phase motors. A distributed type winding is one in which the size of all the coils, the coil pitch and the shape are the same as these are former wound. The coils overlap each other. A single layer winding is one in which the number of coils will be half the number of slots. In short, there will be only one coil per slot. In the process, we shall dismantle the motor, record winding data for the motor, strip the old winding from the stator, prepare and provide slot insulation, prepare and lay the coils for the distributed type winding, make end connections and terminate the load wire, insulate, bind and shape the overhangs, reassemble the motor, and finally test the motor for its performance. You require a pretty lengthy list of tools to undertake this job. The tools are a screwdriver, double end spanner set from 5 mm to 30 mm, ring spanner set from 5 mm to 30 mm, a cold chisel, ball peen hammer, nylon hammer, pulley puller, center punch, insulated cutting plier, hacksaw of 30 cm, steel rule of 30 cm, a scissors, soldering iron, multimeter, 500 volt mega, and ready-made former of universal size. Before dismantling the motor, collect details from the nameplate and record it in the table. To dismantle the motor, remove the pulley by using a suitable pulley puller. Remove the fan cover and then remove the cooling fan blade assembly. Mark both the end covers with distinguished markings and correspondingly mark the body also. Remove the end shield covers. Separate the stator and the end shield cover by gently tapping with a cold chisel. Pull the end shield cover along with the rotor and shaft. Hold the shaft, rotate the end cover and tap it lightly to remove it from the rotor. Remove the grease cup screw. Loosen the bolts gradually, switching from side to side till they can be removed. Inspect the rotor for any visual defects and check the bearing for its condition. If the bearing is worn out, replace it with a new one. Keep all the dismantled parts in a separate tray. Before proceeding further, record the number of coils, number of poles, number of slots, pitch, the overhang projection at both ends of the stator in the table. Open the end binding of the end and load connections from the overhang. Trace the group connections and make a diagram of the same for your reference. In the case of whole coil connection, number of coil groups is equal to number of faces into number of poles. Whereas, in the case of half coil connection, number of coil groups is equal to number of faces into number of pairs of poles. So, ascertain the grouping and connections. Cut off the coils in the non-connection end and that of the stator with a chisel. Remove one or two coils as a whole without cutting to enable measurement of size. Record the total weight of the coils, count the number of turns, measure the size of the wire and record them. Get the slots cleaned thoroughly. Verify the overhang projection, clearance and size. Now, we are going to see the insertion of slot insulation. Check the slot dimension and record it in the table. Check the core thickness and record it in the table. Select the slot liner of the original thickness. Cut the paper with some additional length of 10 to 15 millimeters so as to make the insulation paper to project out on either side of the slot. Cuff either end of the slot liner and fold the same to the slot size. Insert slot liners in all the slots similarly and see that the slot liners project evenly on both sides of the core. At this juncture, check the group or lead connections as per the diagram made earlier and also draw the developed diagram of the winding for the motor. Now, the next task ahead of us is to prepare the coil winding using a former. Select a suitable size of former according to the dimensions, leaving 15 centimeters of extension wire. Wind the required number of turns as per record. After winding the coil, tie it tightly with a twine thread on either side. Leave an extra 15 centimeters, cut the remaining wire. Check it by inserting in the slots. Continue making the required number of coils only if the first one is found correct. Else, make the necessary alterations. Then, shape all the coils by folding their ends. Tie the connections with overhangs and shape the overhangs. Check the winding for its circuit and insulation using the multimeter and megger. Measure the resistance of all three phases. They should be equal. Measure the insulation resistance between the windings and the stator core and record the value. Also measure the insulation between the windings. The values should not be less than 1 megohm. Then, get the winding varnished. Assemble the motor and load test it for a period of 8 hours. In this exercise, we learnt how to rewind a three-phase squirrel cage induction motor which has a single layer distributed balanced winding. Some three-phase induction motors have a double layer in the sense there will be as many coils as the number of slots. In this type of winding, each slot contains two coils sides. That is, the bottom half contains the left coil side of a coil while the top half contains the right coil side of some other coil.